Hello, Flat Earth researchers, debaters and debunkers. I heard an anti-Flat Earther say the other day that perspective is the linchpin for Flat Earth. And he is correct, because we have to be really, really clear about what perspective is, how it works, and how we have been misled into believing the optical phenomenon or effects associated with the human eye perspective are what have given us this imaginary globe. So there's still confusion about what eye level actually is and horizon. So what we have here, you can see that someone is above a surface. It doesn't matter how high above the surface they are. The surface might be part of their field of view, which expands, something like this, okay? So wherever you are, you're going to have a field of view. And in that field of view, when you are looking horizontally, that is perpendicular to your vertical, okay? So when your line of sight, okay, we can call this a line of sight. Okay, when your line of sight is horizontal, perpendicular to your vertical, above a flat surface, that is your eye level. So your eye level always remains in the center of your field of view, as long as you look straight ahead like this. So as you go up and down, your eye level will remain at your horizontal level. So yes, you could go up 100 meters, 200 meters and say your eye level is 200 meters, as long as you look straight ahead along that line of sight. That is your eye level. If you looked down at something on the earth, then you direct your line of sight down here. So your field of view is now different. It's going to be like that. Yeah, you tilt to look down. So yes, you are tilting down below what was your original eye level with your line of sight. So your eye level now has nothing to do, or your eye level then has nothing to do with you tilting down here. This just becomes another line of sight when you direct the center of your vision here. So you cannot say that you are 200 meters high in the air looking this way. This object is not within your eye level. It's not your eye level. It's part of your field of view, but to bring it in line with your line of sight, you have to look directly at it so that this object is in the center of your field of view, making it a central line of sight. But of course, it's not eye level anymore, because eye level is when we look horizontally compared to our vertical. So our sight is divided up a bit like this, yeah? The bottom half below our eye level is the surface. The top half is the sky. Now, of course, here, because this is two-dimensional and it's fixed, the moment I rise up, that surface appears to drop. But if the surface continued into the distance, if this was a three-dimensional surface with some depth, then I would see the surface appear to rise to my eye level again. And as I came down, my eye level remains in the center of my field of view, and we would see the surface follow us up in the distance. We can see this here. Right now, if I was looking across a flat surface at this building and this mountain, okay, they are far enough away to appear to be on the horizon. Okay, so they are now above my eye level. If I am looking straight ahead, parallel to this flat surface, and I will see that flat surface appear to rise up just like this wall does here at my eye level. Yeah? Okay, so I could get further and further and further away from those buildings, the building and the mountain, and the flat surface would still appear to rise to my eye level, but the building and the mountain will have appeared to shrunk in the sky portion, the sky half of my field of view. So they will have gone down in perspective, in angular size if you like, because I've got further away. I come closer and closer, but not far enough for them to be below the horizon, and they are still on the horizon. So what would happen if I'm closer now, if I physically raise my field of view looking in the same direction, my eye level remains level with my central point in the field of view as I'm still looking horizontally. So what we would see then is the surface in the distance remain at my eye level, come up to the halfway point, the horizon line in my field of view. So this is my horizon, okay? Yeah, and as you rise up, eventually you could be higher than the mountain, in which case you would have to angle down to get it into the center of your field of view. But you could be higher than the mountain, and the surface beyond the mountain would appear here still in the center of our field of view, our horizon, our own personal horizon. And if we got so high that we couldn't see much of the surface anymore, we would actually be above the clouds, and then we would have clouds above us. So then the clouds below us would become the surface in the lower half of our field of view, below our eye level, and the clouds above us would become the sky. So in the middle of our field of view, we would still have a horizon, but we're not looking at solid land anymore. So all the clouds above us will appear to descend towards our eye level, and all the clouds below us will appear to rise up to eye level. So we will still have a horizon in the center of our field of view, even when we're in the sky, to tell us the difference between up and down. And we would know, if we tilted, that we are no longer level, okay? So eye level is this horizontal line in the center of our field of view. And it so happens that when we look across a flat surface, short or long, that surface will appear to rise to the midway eye level, that horizontal line that splits our vision between the surface and the sky. In fact, I can just if I put this camera down here, you can see that the end of the table here, this is a flat-ish surface, and the end of the table appears to be at our eye level. Of course, because this table is short and fixed, I raise it up, then my eye level remains here, but of course the surface doesn't extend far enough for it to come up to my eye level anymore. Yeah? So let's have a look at this effect with these bottles here. Okay, there's a very, very slight curve, but it doesn't really matter too much. But you can see here that when you look at them from this angle, yeah, if I put the easiest thing is to put the camera on the floor, okay? So my eye level is in the center of the field of view, and because we're close to the floor, then we can see that the surface rises up to meet our eye level, okay? So the bottom parts of these bottles here are still part of the surface, but anything of the bottles that is above eye level is considered part of the sky in our field of view. So we have these solid objects where the bottom section is still part of the surface in our field of view because we are low, and the top halves are part of the sky in our personal field of view. So of course, if I rise up like this. I'll just get it fairly close, okay? My eye level is here, okay? And of course you can see that as the bottles go off into the distance, we've got two things happening. We've got everything above eye level, that's the top halves of the bottles, appearing to sink down to eye level. And then we have everything below eye level is part of the surface, and these are all coming up to our eye level. Yeah? But then when we go above the bottles, we have the same thing happening. And the bottles, because they are now all below eye level, they appear to rise up to eye level as far as they go. If they went on forever, we would see that. Yeah? Okay, so the higher we go, keeping the camera level, the more they appear to rise up in the distance. The lower we go, the more they appear to sink down. It just depends what is above your eye level and what is below your eye level. Here's an example of the camera on the floor and the camera's eye level represented by this horizontal line that goes directly across the center of the field of view. So as we can see here, the base of the camera is about where the base of the bottle is, and the eye level, the center of the camera's lens, is here at this level. And we can see that the surface that is beyond the bottle extends beyond it and rises up to our eye level. And this remains so whenever we rise up. It just depends what's on the surface. But as we see from this shot, I'm now level with the top of the bottle, and so the lower half of our field of view comprises the surface. It's also, which also happens to be level with this wall here before the fence starts. And then if I go up again, the bottle is down here in the bottom of my field of view. My eye level is still up here, but now it's level with the fence. But again, whatever is below eye level really is the surface. If we could see further and further away, if there wasn't anything else beyond the fence, then the surface would rise up to that eye level. Here we are on a level that's slightly lower than the bottles, but our eye level looking straight out is there. So everything below eye level appears to rise up to eye level, including the floor. You see, everything angles up towards the eye level. It won't go any higher than that. The wall starts there, and everything else above eye level appears to come down to eye level. Here we are, our level, our eye level, a horizontal eye level is in line with halfway up this bottle. And as we can see here, that everything below eye level appears to rise up to eye level. Everything above eye level appears to rise down to eye level. Same again. And here we can see that we're higher than the bottles now, so they appear to rise up. They comprise now the surface of the lower half of our field of view. So these are the same as something on the surface in the distance, but they're not tall enough to become part of the sky above our eye level, because we are already physically higher than them. Here again we are almost in line with these bottles, but we are still higher than them. Our physical eye level is higher up than the bottles, so they from here appear to rise up to eye level. They won't go above eye level unless our line of sight is then, or our eye level is lower than the tops of the bottles. As we said earlier, perspective is the linchpin for understanding flat Earth. It's also the key to deconstructing or reverse engineering the globe and seeing how perspective of the observer has been translated into an imaginary globe Earth model with an orthographic view having us on a curved surface by basically translating perspective into this imaginary curve. Bearing in mind that all observations to do with creating the globe model are observations of the sun, moon and stars in the sky, which is above our horizon, which is the celestial equator, which is 23.5 or 22.5 degrees from the other equator. So we have these angles here that we get from perspective that must be somehow compensated for in the side-on view of us on the Earth. What we get here is a triangle, and we know that if we have an angle of 45 degrees here, then the other angles will have to make it add up to 180 degrees. So we get, with this one, we get 67.5 degrees here and 45 degrees here, adding up to 180, which of course is the same as a semicircle or hemisphere. So we are getting into this crossover with geometry, and when we're working with angles and ratios, the actual numbers and distances, etc., that we use don't really matter. We can create models with any kinds of distances by sticking to these ratios, and they will translate, as we said, with 180 degrees in a triangle. This will translate into a circle of two semicircles, 180 degrees each. The interesting thing, though, here is that this angle here is split by our eye level. So we end up with 22.5 degrees for this angle coming up from the surface to the eye level, and 22.5 degrees for this angle coming up from the horizon for objects coming up above it into the sky, basically by dividing 45 by 2 gives us 22.5 on either side. So this now represents this angle here above the eye level and up here, and this angle 22.5 degrees down here is this angle between the eye level and the angling down that we see here, that follows the line of the bottoms of the bottles and the tops of the bottles. And what I could do now is just show these spots represent the top and the bottom of the bottle here. So in the orthographic view, we would then get this bottle, the second bottle, being the same height as the first bottle. So already we can see this deviation from the angles. Yeah, we've got now we have a different angle going up from the center or up from the side, wherever you want to go up from. It's obviously different in the side-on view because we're not using perspective, but we can see here that if we keep, so this circle up here represents the top of this bottle over here, which should be up here in the orthographic view, but in our view with our human eye perspective, it appears down here. You can't deny this as an optical effect. We know that these bottles are all the same size, so if we line them up, then they would be the same height and they would be on the surface like this. But because of perspective, they appear to
go off like this. They don't remain the same size in our vision. So the further away they get, the wilder these angles become that are different from the angles that we observe. So if we just go into an orthographic view here, so what this view does is try to factor in perspective as well, this angling down that we see of everything above the horizon. The horizon has already been brought up to his eye level, which would be, as we saw just here, a 22.5 degree incline up to eye level, but that's just there. It's just a given that the horizon is already at his eye level. So the thing is, this is missing from most of the side-on views that we have when people are trying to model a flat Earth. So what we have here is the sun going off into the distance, keeping a horizontal line because it's keeping a consistent distance above the surface of the Earth. So we have this parallel line now of the surface and another line above it of the sun going off into the distance. But as we know, the parallel lines never meet, but in the eyes of the observer they do appear to meet. So we have to have the sun, as it gets further away, appearing to come down because of perspective, because it's in the sky, just the same as the trees. The tops of the trees are in the sky, half of the observer's field of view. So the tops of the trees will appear to sink down towards the horizon, as will the sun. It will appear to do the same thing. Naturally, this is just the way perspective works, even though we know, for example, that the trees off in the distance remain the same height as does the sun, but they are going to appear to get smaller from the observer's perspective, and the sun is also going to appear to shrink down because of the observer's perspective. And we can see here how easily we get a sunset with the sun already. Even if the sun is over here, it's now beyond and behind the tree. This observer will not be able to see the sun over here because the tree's in the way. And we can imagine that if we go to a view like this, for example, where we have a mountain in front of the observer, and if you don't want to compensate for the change in size, then fine, you can keep this mountain large like this in proportion to the observer and make it go very, very, very far away, but you still will have the mountains cutting off the observer's line of sight to the sun. So as the mountains get further and further away, this observer's line of sight will decline, as it will as the sun gets further and further away. But you can see here that, for example, if the mountains don't cut off the sun, then the clouds will cut off the sun, because the sun is higher than the clouds. But what would happen is the clouds would appear to sink down towards the horizon, and they would also block off the more distant sun. So whichever way you want to work this model, if you factor in all the other elements that are involved in what we see when we look across a scene as an observer like this, then you do get your sunsets. You do get your angles on a flat Earth when you factor in perspective. And this is what people are not doing. They're not factoring in perspective. They're imagining there is a curve because things appear to get closer and closer to the horizon. Perspective is the imaginary curve. And you do have to make a bit of an effort to get your head around it, but it's not that difficult. What's difficult is accepting that we haven't seen it until now. Thank you very much.